Hey guys, welcome back to the channel. I have another interesting video here. This time I'm working on a 2005 Jeep Grand Cherokee, Jeep Wrangler 4.0. This is for a very good friend of mine, Keith Defazio. He was working on this car. You will see a couple of videos that he got on this Jeep Wrangler, and he was having issues with the O2 sensors. First, I thought it was the O2 sensor heaters, and then he was trying to guide me a little more on the sensor ground or signal for each sensor. I still am doing my own testing here. As you can see, I got everything ready to go, and I have the actual computer talking. I got the oscilloscope connected. I got a logic probe, and I'm going to do some tests for you guys to see this, and also for Keith and I, because I want to pick up his brain, see what tests, because honestly, he didn't send anything with the computer. I need not even have the VIN number yet. This computer has been here for probably, I don't know, maybe 12 days. I spoke to him one time about his concerns with the computer, and then I went and tried to visit the videos that he did, but he usually recorded very short videos, so I have not been able to really narrow down what exactly his problem is, because I know that he does really good testing and everything, but I cannot reproduce what his problems are as far as I understood, or from what I understood from him. All right, so but going on to the computer, I want to do some testing here. I am ready with Identifix, some information. Let me just go over to the folder that I have for the computer. Let me just show you a picture of the other side of the board since I have it backwards. As you can see, I do again my own homework, and I have mapped out, the connectors. This one has, even though it looks like it has four connectors, it only has three. And you will see in your vehicle, let me just, C1 will be the connector that has no colors on it. They call that black. And then C2 orange, C3 which is white in here, they call that natural. Don't ask me why, because that's white. And then C4, again in green, is not used on this one because it's a manual transmission. Yeah, so you guys understand what I have here. As you see, I have, stars and rum and some other uh, symbols that I use, and I put everything on here because I mapped out, inside the computer where everything goes. If I zoom in a little more, you will see what I'm talking about. Then I follow every single component all the way down, or signal all the way down to the microprocessor. When is the microprocessor or the O2 sensor heater control? And I did that for this computer. Well, let me go back. Well, actually, I can use this. These are the connections that I'm using as far as communication. I'm probably going to connect a little more in a second as far as the signals. But I wanted to talk to Keith first and get a little more information so I don't waste my time. And like I said first, I not even have the big number, or not a brief, not even a brief. In this case, for something that is specific, I need a whole story exactly what's going on. But yeah, so again, just more pictures. This is just the first picture that I take from the computer, and that's it. That's as much as we got. And then I have, let me see if I have, yeah, I have this open. I usually go to Identifix, which I like, I am actually paying for Pro Demand, and I'm about to cancel their subscription. I am not really happy for what I can use with them. I like it because I was trying to use it with, with the Snap-on, but they don't have any original wiring diagrams. They're really a little behind on the technology that I can use with Identifix. So why would I be paying for both? They're not giving me anything else that I already don't have, or something that I don't have with Identifix. So I'm sorry, but I'm gonna have to cancel my subscription with them. Well, at least that's how I feel for now. But yeah, so what I can use, and you can do this in Pro Demand or Shopkeep Pro, is in here I got the color O2. So what I did in this one, you can see everything else is grayed out. I just have the, the O2 2 1 heater control, 1 heater control, and these are the O2 heaters control. Again, you can do that in Identifix. I let me just actually go over to the folder because I have some more. So those are O2. Let me see what I named those. Engine Colorado 2. So that's the signal return. Let me get the power supply there as well. So I got the power supply. I got what else is in here? Circular voltage. Okay, this is the same folder or file that I have open right now on Identifix. This is a very good information that I found by doing my um, findings. Looking for information. So grounds and communication. And then you also have, or I also have, we don't really need for what I'm doing, all the connector 1, 2, and 3, all the pinouts. I'm going to open one so you guys can see exactly what is in there. But again, connector 1, they call that black, and it's because there's no other colors in it. Whereas so this one, so on the signals, on the O2 sensor, this is the O2 sensor signal return, and this is in connector C1 pin 32, and then in connector C2 pin 32. Inside the computer, these are interconnected. That's just a signal return that actually is a bias voltage signal return. I'm going to explain that a little further as we go along the video. So we have, what I have now selected all the powers in here. I got fuse, ignition, and connector C111, and then a battery, constant battery on C129, and so on. You'll see that, I have in that picture that I showed you before. Let me get to one of the pictures. I mark all these in here. So I have, powers in C1 and pin 29, ignitions in 11 and 30. And then I got the SD relay, sorry, my tongue, SD relay on 19 and 20. Those actually are providing power for the computer as well. And then I have grounds and connector C1, 9, and 18. I got also the communication lines, what I need in here, they're only C1, again, connector 1, pin 38 goes to DLC2, pin 36 to DL7, and pin 25 to connector DLC pin 12. The O2 sensor grounds, again, in C132 for 1, and 2, and I have also C232 for connect oxygen sensors 1, 2, and 2, 2. What else? Grounds and communications. I will explain that again. This is just a wire diagram, how I got and gathered that information for making my connections. And if you want to see, the connector is they're all 38 pins. They're going to look the same. And this is the pin outs on connector 1. Like I showed before, I always like to double check, make sure that what that wiring diagram, because it's a color wire diagram, probably redrawn by Bosch, and then I can take the connectors and make sure that, because this is original information, that everything matches what they have in there, and it did. So I have everything connected. I can then also show I have the oscilloscope connected to one of the O2 sensor signals. I am in connector C132, and I have this blue lead right here on connector 2C2. This is the other O2 sensor signal return, and that's how Jeep describes it. The rest are just the connections for powers and grounds and communication. I can see those values in the scanner. This is very nice from top down. Probably or most likely you will have the same hidden in all the manufacturers or aftermarket manufacturers for the scanners, but this is very nice because I like the screen size and everything on this scanner, then I have everything in one place. All right, so if we see I have O2 sensor voltage 5 volts 1, but it also says also 1 O2 sensor voltage 0 to 1 2.43. What is this, right? You will say, why is two voltages? Well, this sensor uses bias voltage on the sensor ground. The sensor return is actually not a full ground. This is going to be biased to 2.4 or 2.43 or so. And then as the temperature in the heater of the O2 sensor changes, the ground or the resistance on the sensor will change, and that will make also that ground be a little stronger and then bias the signal up and down as we are normal to see. And then you can transfer that, or the scanner can transfer that to a different value. But if you try to see that with an oscilloscope, you will be seeing 2.5 volts. I want to share this information. All right, again, I found this in Identifix. Let me go up to um, default. So you can have either P0131, P0137, P0151, or P0157. They're all for the sensors, for the all four O2 sensors, 11, 12, 21, and 22. For those that don't know what that means, is sensor 11 is the upstream, and sensor 12 is after the catalog converter, or what we call downstream. All right. So that means that these tests is for all the sensors. So it can be done in any of the sensors. So they're saying when monitor engine running for less than 30 seconds and the O2 sensor heater temperature is less than 250 degrees Celsius with battery voltage greater than 10.4 volts, the condition to set default, the oxygen sensor signal voltage is below 2.4 volts for 10.24 seconds after starting the engine one trip full. And it's the same for all the O2s. So as you can see, if we read this information, it's just a copy and paste of the same on every single line. So you can do the test on every O2, it's exactly the same. So they're asking for no less than 2.52 volts with the engine uh, cold, let's say, because if you had 484 or less, let me just see, engine running for less than 30 seconds, the O2 sensor heater temperature is, less than 251 degrees Celsius. So less, it can be from 0 to less than 240, sorry, 484 Fahrenheit. But then reading more down on the testing, again, let's disregard for what sensor is. Now we know that we can apply this to all the sensors. And this is what I want to ask Keith. So start the engine, allow the engine to reach normal operating temperature. When diagnosing this DTC, diagnose the O2 sensor that set the DTC. All right, well, obviously, in this case, I don't know if he has any sensor codes for those O2 sensors, but that's what I want to talk to him as well. So read the O2 sensor voltage again with the engine running and allow it to reach normal temperature. Is the voltage below 2.5 volts? So if it's yes, then you go to 2. If you know, that means that it's an intermittent condition. Perform power trend test verification. So if the sensor voltage is higher than 2.5 volts or 2.52 volts, it's okay. If it's below that, then it's not okay. Then we are going to say that it was, we're just going to follow this. Turn, and like if we say yes is below, we're going to follow to number 2. Turn the ignition off. Disconnect the O2 sensor harness connector. Again, ignition off, that means engine is off. Disconnect the O2 sensor harness. Ignition on, engine not running. Monitor the O2 sensor voltage. Is the O2 sensor voltage above 4.8 volts? And this is what we're seeing in here. Ignition off. Well, in this case, now it's ignition on because they want you to disconnect the O2 sensors. We have no O2 sensors connected in here, right? So this is kind of like that test. So with the ignition on, engine not running, is the voltage on the O2 sensors above 4.4 volts? It is 5.9, 5.12, 5.12, and 5.12. So all sensors signal our reading, and you can remember we got 2 voltages in here, one on the signal side and one on the ground side or signal return. That is what they call in the sensors. If you say yes, Is the sensors above? Let's say, okay, yes. Measure the voltage on the O2 sensor return circuit at the O2 sensor harness connector. Is the voltage at 2.5 volts? Well, we have 2.45. Let me just go 2.43, 2.45, 2.45, and 2.45. So let's say, again, measure the voltage. Is the voltage at 2.5 volts? I will consider that as yes. Replace the auto sensors. That's it. If we say no, then the computer, or not the computer, the chart is asking to perform further testing. The only thing that I need to run with Keith, and I'm probably going to do this as a part one video because I'm going on more time than I was supposed to. Um, if I look at his video, he wanted to have with the engine running less than 2.5 volts on the auto sensor. He wanted to see 0 to 1 or 0, like 0 to not really 0. Let's say 200 millivolts to 800 millivolts. I need to see exactly what he was doing his test because based on this chart, I am not seeing how will I expect that. Because again, start the engine, allow the engine to reach normal temperature with the DRB. This is the Chrysler all scanner. Read out the sensor voltage. Is the voltage below 2.5 volts? Yes. So if it's 2.5 volts, it's a problem. Below 2.5 volts. If it's above 2.5 volts, it's no problem. Refer to the intermittent condition for the procedure. Let me just show you a little bit of his video, and this is what I am a little at loss because I want to see exactly what he was doing. All right, guys, this is the test that he was doing on the vehicle. At this time, he is actually running, as you can see, he has auto sensor 1.1 and auto sensors 2.1. Remember, I'm going to go back and forth a little bit on the information if I am able to do it. Yeah, I'm right here. So remember, start the engine, allow the engine to reach normal temperature or normal operating temperature. Is the voltage below 2.52? No, and then it's an intermittent condition. If it's below 2.52, that's the problem. So we are going to see his video. It seems like he is just, in this case, starting the car and not idling, revving a little bit, and you can see the temperature drop. Let me make this bigger. But as we can see, we got 2.7. Look at these values right here and then right here. So hopefully the camera, okay, right, probably that distance is right there is the sweet spot. So we don't see the many lines in there. But you see 3 point something. And so this is actually uh, what I would consider to be a normal signal. I don't know if I'm reading the information wrong or something is not matching. So this is the sensor ground. He has back problem on the sensor ground. He's going to use a test light to first to power, trying to get that ground to light up that. But again, for what I read and for what I see on the computer, this is not a normal ground circuit of an auto sensor. You cannot use this because otherwise what he's doing in there is pulling it back to the 5 volts, which is through the sensor. The 5 volts will go through and then looking for kind of like a floating ground. Let's call this like a floating ground. If he releases that and then it goes back to like that sweet spot that Jeep is looking for. Now he's putting that test light to ground and he's trying to ground that sensor ground, which I mean, if you do that, it will pull it lower than what is supposed to. And then remember, he's pulling the sensor ground, not the sensor signal. But obviously, if you pull the sensor ground or you make in this case, you give it a better ground, let's say not the ground that the actual sensor is supposed to have because it's a biased voltage, um, you can change the position of the signal, and that's the only thing that I can see in here. But I'm going to stop the video or his video here. Based on the information that I see here, that sensor should never be on 0 to 1 volt. It should be right in 2.5 volts and up. Again, this is the sensor signal. That's I need to talk to Keith a little more and then go from there. So this is going to be part one of my findings in here. I do see some heater issues with the rear O2 sensors. I know I'm going to make this video a little longer, but things that I want to share right now or right away with you is this. I want you to see, I'm going to, let me go back and I'm going to deselect now everything except the O2 heaters. So we are going to see just the heaters. Yep, perfect. So if we see the heaters, we got heaters on 1.1 and 2.1 at 20%, but the two heaters for the other ones are in 0, which is the downstreams. If I provide, I have now, this is I think for 2.1, if I put a test light in here, remember that's in 20% right there. If I put a test light in here, you're going to see that the test light lights up for probably 3 seconds and then goes away. And now 2.1 is in 0 because that was a check for the heaters. If I move now this pin to the heater, let me stop the video. Well, actually, let me try to do this with you guys in here. So this is 18 and 19 or 17 and 18 in here. Yeah, I can do it with one hand. Now we're going to see that 1.1 is still showing 20%. This is only the test, right? So if I connect this again in here, that test light will light up for about 3 seconds or so. On 20%, if I turn the ignition on and off, it goes like to 100 for like a brief second, but this is normal testing. So and we can see that test light, it goes away, and now it shows 0. So I'm going to disconnect this test light, and I'm going to turn the power off here, probably for 3 seconds or so. So 1, 2, 3. I'm going to power on and look the heaters, just 1.1 and 2.1 are going to change. These two are going to stay like in nothing. So power is now on. You see the two upstream heaters went to 100 and the two downstream didn't do anything. So for me, we have a problem with the heater control circuits on the O2 sensors, not with the actual sensor signal or sensor return. And this is what I want to share with Keith. I do have parts coming for the O2 sensor heaters. I already explained him that that's what I see in this computer. And this is what I want to share with you all. I am also using, and this is from SIA Electronica. This is a nice test light that I purchased with that same full probe and everything from SIA Electronica in Argentina, for those who wants to know where this is from. The nice thing about this is this light it has lights on it. You can change the tip, and you can put like any type of connector or terminal that you want. It comes actually with a nice assortment that you can use. The other thing that I like is if I check if I touch the ground, like a normal test light, let me just go over to a lower one. You see how the back goes into green, and that means it's open, so nothing, no power, no ground. If I touch a power, let's say right here, the reason it's doing that is because if I press this, you see how this blue light went off? When the light is on, it's looking for 5 volts. So when the light is on, 5-volt test light, when it's off, I can now use it with 12 volts and I have a red light. You see that? If I look for a 5-volt reference in here, that will light up if I have a 5 volts or a sensor ground or so. So this is a very nice test light. I like to always get as much as tools I can for my testing, and this is very good from CIA Electronica in Argentina. All right, so I think I'm going to stop the video. I hope I didn't miss any information that I want to share with all of you about this one and with Keith. I'm going to contact him as soon as I have this video up and running, and then go from there. All right, guys, expect the second part on this computer. Again, from my friend Keith Defazio. I'm going to put a link on the description to his channel. And for those that wants to see his channel, I know he's very famous, so it's just New Level Auto. So he's he is a guru of diagnostics. So that's what I want to see exactly what he tests, because I know that his tests are good. I just want to make sure that, because we are humans. He can make a mistake, or I can make a mistake. Am I the one missing something, or he is the one missing something? Two heads, we can put it together, think, and make it work. All right, guys. Talk to you later. See you next time. Bye bye.